why this PSL is uncomfortable is because you have to so I mean, if you re-explain this whole problem in terms of like a basketball court, I would get it. It's like you can picture it in your head. This one, the difficulty is you're trying to picture something that's weird in your head. So what's going on is you have two drones. One is a reconnaissance drone. The first set of questions are just about that reconnaissance drone, the recon drone. It goes up to an elevation of 300 feet. And then you have everything happening at 300 feet. It's like you went on a plane, you're 300, it's 300 meters. And I don't think that matters that much, but 300 meters, you go up and you're just hanging out like on a field at 300 meters high. That's what's going on. So at the first step, what you're doing, what are we trying to do? I don't have this broken out by task. I have it broken out by just what is going on and what are they trying to do. So the first step is, and I'm going to send you to boards for some of this so that I make sure that you understand it. And I'm also going to check that I'm not having a party up here by myself. And I'm going to check that you guys understand what I'm doing. So you're given 3D points. There's 3 checkpoints, or there's a checkpoint. So it's this drone is taking off. It reaches 300. It starts at the origin, and then it goes from checkpoint to checkpoint. The displacement vectors that you're first drawing and figuring out what they are actually, the purpose of that is to show you that the vectors with the arrow represent particle movement. So you're given 3D checkpoints for a recon drone, starting with takeoff, and then reaches 300 meters, and then you reach checkpoint 1. That's where the story starts. And then you have a sequence. It's going to go from checkpoint 1 to checkpoint 2 to checkpoint 3, ... all the way to checkpoint 6. The displacement vectors, you start at the last position, and then you take the next position, and you subtract, and that forms a vector. When you plot that vector, it has an arrow to it. So the first one starts, who calculated the displacement vectors? Who's done it? Okay, I'm going to get Lucas with the first one, and then Julia with the second one, and then you just imitate me, but you do have to understand under the hood what's going on, because if you get a problem like this, let's say on a WPR, it's going to crush you if you don't understand what's going on, right? I can just change the scenario, and it's going to be very weird. So make sure you understand me. All right, so checkpoint 1, I'm drawing this with X and Y because Z doesn't count. That's the first, I would say, cognitive burden when you're looking at this. You're looking at this and going, 3 dimensions. I have to understand 3 dimensions. You don't. It's like this is 300 feet, and you're looking out on this field 300 feet, and this vector is moving. This drone is moving around. The first point it starts at is the 0, 0. What's the next point it goes to? Interactive. Huh? 500, 200. So X equals, let's do 100, let's do 200. By 200s, 400s, 500 is here somewhere. And then what was the other one, 200? So you're here. So your first displacement vector is this guy here. And the formula for that vector is 500, 200. And the way you get it is you take the original location, which was 0, 0, and you go tail to head. This point's value is 500. 500 minus 0 gives you the first coordinate. 200 minus 0 gives you the second coordinate. Where does it go next? Somebody louder.
If we reach to 100, 500.
Okay, so that's over here, 100, 500. So it goes up here. So then I need to figure out what the displacement is between these 2 points. How do I do that? Right. The coordinates of this, like the coordinates are 100, 500. The way you find the vector, the displacement vector, is you go tail to head. So you go 100 minus 500. I'm just making sure I wrote everything up right. 500 minus 200. That's your second vector. That's your displacement between these two. And then go on. For all 6 of them, you'll have it. And if you think you're just connecting the dots, you're not. They want actually the formula for those displacement vectors. If you think, well, they didn't ask me, it'll be on a rubric. So I have to go and say, did they put this in? So make sure you have all the displacement vectors, one for checkpoint 1, one for checkpoint 2, and so on. Each one of them.
What's the symbol for displacement vector?
It's just, what's a vector?
So like blank equal, like in
Negative 500.
like you know how there's like a D and an arrow or something? Like what's the thing?
All vectors have an arrow on top of it. It's just a name. It's like X. So I don't know what you want to call it. You can call it displacement 1 with an arrow on top of it. Vectors have arrows on top of it so that we know that it's not a real value. It's a vector. It has more than one.
Okay, so it's not just like value D.
No, there's no like special thing for it. You can call it whatever you want to. You can name it each one of your displacement vectors after people in the class, as long as it has an arrow through it. Chris, arrow through it, is displacement 1. Nick, arrow on top of it, is displacement 2. You can call it whatever you want to. Just make sure the arrow's on top. Okay, you have a question?
Let me like talk about this and tell me if I'm wrong. See if I understand. So we need to have the displacement vector for each point, right?
Yes.
So the like it's basically just from like your last point to your next point. That's the displacement vector.
That's correct.
Why does it seem so? Why does it? The question made it seem so like crazy.
It's how we read things. So I took some of the questions that they're asking in the WPR and I just changed the scenario to something that I think I understand better. Just picturing all this, and also there's irrelevant information. I didn't really need to know it went up to 300, right? So I don't need the Z. So all of that makes it so that it's hard to understand what the scenario is. The point about scenarios like this that I've heard is that they want you to understand how to take complex information and then digest it. But in a real life problem, you'll know the situation. So you won't have to figure out, like, I have irrelevant information here. That's not how it works. Whatever it is, that's what's going on here. So I'm pulling that out for you and telling you that's what's going on here. If you get a new scenario like this, you need to do the same thing. You know, figure it out what's going on. And it might be a physics scenario. I don't think it will be, because I made a vote for it not to be. All right, so that's part 1. Then the second part, not second task, but the second thing they ask you to do, my second thing they ask you to do, is they ask you about the last leg. So from checkpoint 5, so second, can I just call it thing? Like on a Wednesday. From checkpoint 5 to checkpoint 6, last leg. It concentrates on that last leg. And it asks you to move, you're moving from minus 300, minus 300. So you're down here at the bottom, minus 300, my sloppy graph, minus 300, down here. And you move back to the origin, 0, 0, like here. So that's what you're doing in your last leg. And I think somebody said in class, we're just coming back around to where we started. And you want the displacement vector. And they say that you're moving at a speed of 22 meters per second. So the question that you were asked was, compute that displacement vector. What would that displacement vector look like? The last one. 300, 300. I want to call it Chris with an arrow on top of it because I thought he'd like that, but I'll just call it displacement vector.
So the displacement vectors, are they ever negative or it's always?
Yes.
But then wouldn't,
I just did one. No, I didn't do one. Yeah, I did one up there. Minus 400.
if you're subtracting the one you're starting from to the one that you're going, then wouldn't that?
Zero, but these are negative numbers. So you're starting from minus 300 to minus 300. And then you're ending up, you're subtracting tail to head. You're ending up here. Your tail is 0. So 0 minus the minus 300 gives you a positive 300. And 0 minus the minus 300 gives you a positive 300.
Okay.
So displacement with an arrow on top, just to let everybody know I'm working with vectors, is 300, 300. That's the displacement. Then you're told that you're asked to do a bunch of stuff. You're asked to make it a unit vector. That's the stuff that we were stuck on the first day. And I think everybody knows what it is. You take the magnitude of this beast. I wish I didn't call it displacement. I've been using double lines to make sure that you know that it's a magnitude. The magnitude is this one squared plus this one squared plus square root, and you get this number. I don't care what it is. Whatever it is. Everybody should be able to calculate the unit vector. You take this beast, the magnitude, and you make it a unit vector. And I was calling it U for unit vector, but what you do is you take whatever that number is, and you divide your original 300 by that number, whatever this is. I obviously did this on a calculator and just didn't keep track of my numbers. And you should get, as your answer, something like this, 0.707. Should get this. That's the unit vector. What does that do? What am I doing visually?
Is the magnitude is kind of just like the Pythagorean theorem.
It is the Pythagorean theorem. So there's a lot of the hypotenuse, correct.
This one changes the hypotenuse.
Yes, you're changing. So you're changing the height. Everything's in terms of, this is called Euclidean geometry. So you really are calculating this length. You're really working with triangles. If you have this in a class where we're doing just vectors, that's what we would be showing you. It's just that you have a lot of content, and it's in the middle of a class. Like, it's not the whole class is about vectors. So I'm not showing you everything, but that is what you're doing, calculating the hypotenuse, and then you're shrinking that hypotenuse to 1. If you divide by the length of the whole thing, you get 1. How tall are you? 5'4". If you divide her height by 5'4", she'll have size 1. Right? That's all you're doing. You're normalizing by the height, or by that length. Nick?
Is that like when it's going from like the base to like where it gets that little problem?
It's just, yeah, for some reason they zero in on this last leg, and all your calculations are about this last leg. The purpose of this question was to teach you how to calculate a unit vector. That's what the purpose was. That was what it was. And also to convert that position, which is a distance, to velocity. So you multiply by the speed, because there's constant speed. They tell you how fast it's moving. The drone is moving here too, 22 meters per second. And they ask you for that velocity vector. And how do you get that? You take this beast right here, and you multiply it by 22 meters per second. So you should get your velocity vector. I'm going to call it VR, because I love my VR. For recon, which is going to be equal to 22 times this guy here, and you get So you're getting some partial answers here. You should get something that's 15.56, hopefully, because I'm terrible at arithmetic. That's the first class I had to teach when I left West Point. I had to teach arithmetic at the college level for people who didn't make it through. They thought I didn't know what I was doing, and I didn't. I didn't know how to do anything without a calculator, but it was, it was a nightmare.
And for the square root of 3 squared plus 3 squared, what is the unit that would be on the end of that answer?
Good question. It's a distance, so meters. Yeah.
Why is it multiplied by 22 again?
Because distance is position times this is the position, and then when you multiply by meters per second, it makes it into velocity. It's like miles per hour. This turns it into a velocity, a speed. So this is like a speed vector.
What's the 22? What number is that?
They gave it to you in the reading. It's like they said that the reconnaissance.
That's how fast.
Yeah. Mm-hmm. Yes. So mixed in this problem, why it's confusing is they wanted you to calculate some things, and they interwove it into the story of the problem. So that's why it's a little confusing here. But that's what they want you to do. They want you to calculate that velocity of that drone. So for me, I made a different scenario. I can imagine, for example, a goalie trying to intersect in soccer, trying to intersect a ball that's been kicked, that's on the ground, that has some velocity to it. So that's like what's going on. They're going to next ask you for an enemy drone to stop it. A goalie to stop a ball. Makes more sense, doesn't it? That's what they want. Banks, you had a question?
Understand like where the drone is and stuff, and like what we're trying to get at the end of. Is there like a conceptual way to understand like the like the first vector, the displacement, and like the unit vector? Like I feel like we're just like writing, not like conceptually understanding.
So I don't think it has a real purpose here, other than we try to make things into a unit vector often. So some of the content you have here was dictated by physics or somebody else in a different department. They want it in here. So somewhere along the line, you'll need to calculate a unit vector, and they wanted you to have that skill. But the purpose is very much similar to a z-score. You're trying to normalize everything so that you can see it. Like sometimes you log transform data so that it's all in one, you can see it. That's why we do it. We try to get everything on the same size so we can see things. I've used it before. I've used normal vectors. Like we call it normal vectors. We're trying to normalize it.
If the drone is going 22 meters per second across the hypotenuse, does it mean it's going 15.56 meters per second to the right and at the same time?
Yes.
Okay.
Yes. That's
So
exactly.
those are still like.
Yes. Those are still meters per second. Yes.
So I'm sorry to do this to you, but it's like in an X direction and Y direction if we're talking physics.
Yeah. So this is like in physics, they'd have a v sub x and a v sub y. Yeah, that's right. Is it connecting physics?
Yeah, when I think about it from a physics standpoint, it's a little easier. I'm sorry to tell you that. But.
No, it's I think a real physics problem that I really encounter. I use physics. First law of thermodynamics, weight change, but that's a scenario that makes sense to me. This is a scenario that's been created artificially, and I'm trying to make sense of this artificial thing. That's, I think, where I was having the problem. And you were too. What's going on here, right? So I'm not giving you all the answers. I'm just giving you some of them so that you can kind of put them in context.
So not super lost.
Good. All right, next piece. Here's where you need we're going to do something called parametric equation of a line. And you guys were asking me a lot of questions about this at the end of class.